This is critical point. And at x equals 0, the second derivative is positive. In this case, at x equals 0, it is concave up. X equals 0 is a critical point. And the second derivative is negative. So it is concave down. Let me give you one example. The first derivative is so x equals 0 and 4. These are critical points. Second derivative is if I plug in 0 to the second derivative, it is negative. If I plug in 4, the second derivative is positive. If the second derivative is negative, it means concave down. If the second derivative is positive, it means concave up. So at x equals 0, it is local maximum. And x equals 4, it is local minimum. And we can also check by drawing a sign chart. The first derivative, if I plug in 0 to the first derivative, it is if I plug in negative, like -1 to first derivative, a negative and a negative makes a positive. If I plug in if I plug in 0, it will become 0. So it means the critical point making a max or minimum. So I need to plug in other than 0 or 4 here. If I plug into 3, positive and a negative, so it makes a negative, and 5, 5 positive and positive, so it will be a positive. So the first derivative like this. So the function is looking like this. So at x equals 0, the local maximum, and x equals 4, the local minimum. So I use the first derivative here and the second derivative here.